Really happy to be here. I am an American, but I've done probably 30% of my work in Canada, in particular in Western Canada. I've been on the boards of a couple of Canadian companies, including Cognos and Simware and Microtempus and some others. And in the main, over the last 30 years, I've been doing technology strategy. Initially really hands-on across the organization, and more recently helping boards, helping the senior executive suite, helping the CIO and the CIO's leadership team really come to grips with how we make some of the transitions that the marketing's driving us to. And so what I'm going to do today is share with you some of the lessons that I share with my clients when giving them mentoring, when I'm doing an assessment to help them get through this. And we're going to just hit a few key points because I could be here for 7 hours, not 60 minutes. It's also great to see George. I haven't seen George in a while. I started an enterprise architecture consulting firm in the early 90s. George was one of my very first customers when he was in the architecture team at United. And then when I took my business to the Meta Group, George was gracious enough to join me and at one point succeeded me at the Meta Group running the EA practice. And George is just great people, and as a delivery mechanism for Michelle, who's now, I guess, everybody's boss. So I'm going to jump in, and I would love to get questions during the session, but if you think I'm talking too fast or you want to chat me up, I'm going to be certainly in the reception after this, and I'm always accessible via email. So I'm going to leave you with a set of takeaways, 9 takeaways. And as I go through these takeaways, what I want to do is talk about some of the experience that I've had in my client base. Cloud computing wins. Cloud computing wins because converged infrastructure wins. I am a deep believer in this for reasons that I think you'll understand in a moment. Now, when I say cloud computing, I have a very specific set of meanings: on-demand services, broad network access, resource pooling, certainly elasticity, and then very important usage-based pricing of some sort, and a usage-based model. It also turns out that when I talk to leadership, often they'll come to me and they'll say, well, Larry, I saw this in Oil and Gas Journal, I saw this in the Globe and Mail. I'm helping IBM with some stuff in E&P right now, and some of the technology they're taking into that space. And you're talking to them, and they're saying, Larry, look at this logging, cloud-based logging stuff that we've got, and I can't believe the price of it. The answer is, you can believe it. The boardroom is talking about cloud computing, not so much the cloud. They're talking about capabilities being manifested on the cloud that drive core business value. And that's true at the director level, line of business level, and certainly in the CXO suite. Now, cloud computing wins because of the underlying economics. George has seen these slides for north of 20 years, the next diagram we're going to do. I update it from time to time, but I want to share with you an economic model that I've taken to every one of my clients, and I drive home. I believe if you understand this model, it'll help you better understand where we've come, where we are, and where we're going to go. In the mid-90s, I wrote a paper on tectonics, and I talked about these powerful forces, immutable forces, that are going to fundamentally drive technology long term. I want to share with you 5 curves. And these curves begin on the horizontal axis. I've got time from today to whenever. On the vertical axis, I've got price performance. Let's call it value. So at some point in time, 20 years ago, how much processing, how much software could I get for $1? And then what happens to that buck over time? Well, all these curves have been getting more attractive. In fact, when you look at IT staffing costs, they've actually gone down. When you do a full balanced pot, because of labor arbitrage and offshore and all of those things, staffing costs on a whole dollar value, the amount of work and the quality of work we get for that dollar has improved over time. The next curve is enterprise software, and I have had people throw things at me. Enterprise software is actually way cheaper than it used to be. Now, the reason we don't see this is because we forget 2 things. One, the enterprise license is now on way bigger processors. So if you compare the enterprise license on processor value 10 years ago with processor value today, you've got an improvement. But more importantly, what vendors do is they stuff in way more functionality. Microsoft Office. Think of Windows 3, think of Windows 7. The amount of functionality present, SPSS, I was doing some work with SPSS, the old statistical package, you wouldn't recognize it today. So over time, the value equation, the price performance of software goes down. By the way, you're just seeing two critical curves. And what I'm going to stress to you as you go forward is the market will always move, CIOs and leadership will always move to the more attractive economic curve. When you were architecting in the mid-90s, George and I wrote about adaptive architecture and adaptive infrastructure, which HP ripped off, always moves to the next better curve. So if you have a choice, ride the cheaper curve because your costs go down faster over time. So I'll say this again. Build, buy. That's the curve. Now, more aggressive than that is, of course, Moore's Law, which is processor performance. But even better than processor performance is storage. Storage is much cheaper and declining at a faster rate than processors. We tend not to see that because we buy storage in giant step functions. Every 2, 3, 4 years, we buy a bunch more storage. And for many of us, we spend the same amount that we used to do. So it doesn't appear that cost has gone down. But what we get is 6, 10 times the capacity we used to get. And then finally, you got networks. And networks is the most aggressive curve. Tectonics. The market will always move this way. When you can design and architect systems and services, move those systems and services to the most aggressive curve because you benefit in the economics over the long term. Tectonics. You're going to see relentless improvements. We've seen it for 20 years, and we'll see it 20 years going forward. And it occurs for a whole bunch of things, including improvements in manufacturing technology, improvements in yield rates. LED TVs are much cheaper because they produce a bunch more, and their yield rate at the end of the line is a lot higher. When plasma TVs first came out, they had a 5% yield rate, meaning 95% of the plasma TVs got tossed. Today they run 99% yield rates. Whenever Intel produces a new chip, yield rates run 60, 70%. By the time they're a year into that chip, they're running yield rates of 99.5 to 99.9% yield rates. Ride the economics. Relentless price performance improvements. And of course, wherever possible, as I said, architect for the next better curve. Converged infrastructure. Converged infrastructure is nothing more than the recognition a number of years ago by a bunch of former Compaq guys who went to HP, and then a big chunk of them were rated by Cisco, who said, why don't we share a common chassis, common power supply, and bring that together, C-class enclosure. It's one of the first converged infrastructure. So when you look at Cisco, of course IBM's in this space, and HP's in this space, what they're really saying is we can ride these three curves and converge those curves together. And the same thing is driving cloud computing. And what is the key enabling server technology for cloud computing? It's going to be converged infrastructure, tectonics. These are immutable forces, and you can ride them. You can ride them for the long term. So takeaway number 2. Cloud computing taxonomies absolutely simplify comparing and contrasting cloud offerings. And I'm sure all of you have seen the diagram that's based on the NIST. I'm going to keep looking down here at my phone, not to be annoying, but because I don't wear a watch. So I want to make sure I'm staying on track. Okay, so we've got deployment models, private through hybrid. We've got delivery models. You've all seen this, essential characteristics. So this is very useful for comparing cloud offerings, but the simple fact is, when I talk to my clients, you spend way too much time trying to understand this diagram. You're diminishing returns. You got it in the first hour, spending a week or a month or 6 months to reach a decision through this diagram will not get you there. And it won't get you there because, in fact, the range of cloud options is much broader. And the edges are very fuzzy and they overlap. So we're going to take a look at some of the overlap in these categories in a moment. One thing you've got to take away is that many vendors have got multiple offerings in different parts of that taxonomy. And in fact, what we're able to do is combine offerings to come up with completely new solutions. What I do, what I tell my clients is focused on the management services aspect. Whatever the offering, whatever the apparent deployment model, look at the managed services components that you're competing because that's the value add. It's the managed service. It's not the bare chassis. Now, the bare chassis has an economic value because you can do it yourself. But if you look what's driving the cost in the value equation, it's going to be the managed service. That's where you compare and contrast offerings. So we're going to take a look at that because it can vary greatly between cloud offerings. So let me give you a couple of examples. So I don't use that basic model when I talk to people, because public, private, hybrid are pretty obvious. We all know infrastructure as a service, and we all know about software as a service, and we've got that kind of basic model. Instead, what I do is say, draw this curve. Consider the percentage of managed services component. Is it very high, low, to even non-existent? And then on the horizontal axis, put relative pricing. So I'm going to put extremely expensive stuff to the left and really cheap stuff to the right. We'll just call that comparative pricing. Cost a whole lot of money, doesn't cost a whole lot of money, and then I'm going to draw you a curve. So here's my curve. Now what I want to do for a moment is plot against this curve terms we normally use. So when we look at infrastructure as a service, software as a service, that occupies this space up here. There's a tremendous amount of managed services content. Don't worry about the deployment model. Don't worry about the delivery model. Just think about this service from a managed service component in relative pricing. Then what we've got is platform as a service. And then at the lower end, the space that, frankly, Amazon dominates today is infrastructure as a service. Now, I've done a lot of work with Amazon over the years. I've had a lot of clients put their hands on Amazon, and you either love it or you hate it. That's the simple fact of the matter, because it is roll your own. Try and get a support person on the phone. It is very difficult. Now, it does happen. I've been able to do that. But you're buying bare metal stuff with terrific services on top of it, but you start up an instance and you forget to turn it off, you're going to be billed for that instance. But you can get it cheap, and you can get it dirt cheap. And I'll tell you, there are some things that are very attractive about Amazon to understand in terms of where the market's going. That's not a recommendation. Drop everything you're doing and think Amazon equals cloud computing, because that's certainly not the case. So what I want to do is take a moment and illustrate that I can go to one vendor and wind up at very different points on this curve. In fact, what I'm going to do is I'm going to start with Amazon Web Services. I'm going to give you 3 approaches to database at Amazon. I've done all 3. So the first choice, cheapest choice, go get an EC2 instance and load on MySQL. It's free. This is cheap. It works. It's really cheap. And you've got to do the management. You need some internal support resources. Typical DBA stuff. And here I'm not talking about the database design. I'm talking more on the administration configuration side. A second alternative, which is going to cost you a bit more, is their relational database service. I've got clients using this. I use this. Great service. And what they've done is they've taken and really created database machines. A MySQL database machine. That's what it is. You don't have to worry about allocation. You don't worry about patches, backups, upgrades, any of that. They take care of all of that. It comes out of the box. Now, it really is a database machine. So you never have to worry about allocating. All that's taken care of, but you can't run any jobs on it. You can't do a cron job. You've got to start that on another server because you don't control the server. The strength of the offering is they manage it for you. The weaknesses of the offering is they manage it for you. And you know what? It's more expensive to run RDS than it is to pick up MySQL and run it on EC2. The third alternative is to use a third party. And here I'm just taking one example from Amazon. And we can look at any set of cloud offerings and find similar examples. You want to have more flexibility than RDS gives you. On the other hand, you don't want to have your staff worried about feeding MySQL because you don't have a lot of MySQL skills, or you're short of DAs and DBAs, any number of reasons. It's a new project, it's a new effort. So what you can do is you can take an EC2 instance, put MySQL on it, and then hire a third party like EDBA or DataVan or any of those folks who basically are in the database carrying, nurturing, and management business. 3 different approaches on one model, all with different strengths and weaknesses. And the simple fact is when you get to cloud offerings, you can't take that taxonomy, take an offering, and shove it in a hole and say, this is always red 32. You can't do that. And the options in front of you, the flexibility, is enormous. But you've got to be willing to take a look at it. The way I always start, look at the managed services content. Worry less about the specific deployment approach that they're taking. Takeaway number 3. Don't try to forklift your data center into the cloud. Don't do this. Don't. And I go to clients and they say, why are you going to the cloud? I want to go there for cost. I'm going to save all this money. We're going to talk about that myth in a moment. But what they really want to do is they're thinking, well, I'll get rid of this big honking data center I have and I'll stick it in the cloud and it will solve everything. So we get one of these. We get an approach that looks like this, and this is just 1990s outsourcing redone. It's exactly, don't take this approach. This is not going to be effective strategy. What do I suggest? Most successful companies, and I'm talking about the ones that I work with, Pandora, that are leading edge and really taking it out there. I've done work with the HP team on converged infrastructure over the years. When I look at some of my really leading edge clients, including the one that went from 0 to 60 in 6 months, what are they looking at? They're looking at what I call the cloud collective. Made that term up because I need a way to describe it. But it's saying I'm going to take a collectivist approach to this thing. So when I look at what my leading clients are doing and I talk to their technology leadership, they really envision that they're going to have a bunch of cloud partners. They're going to have a bunch of them. They may have one that's focused on highly predictable performance, because this particular provider of cloud capabilities is very good when you can say, the performance constraints I have, the box I will stay in will probably look like this. Then there are other providers who are extremely good when you have highly variable performance requirements. AWS is very good at satisfying this need with their on-demand and their spot capabilities and that. Of course, it has the management issues that I highlighted a moment ago. Then they say, in addition to those two, now that might be the same provider, but they're very different services I'm getting from that provider. The third class is, I want on-demand, but I want it for development and testing. I want to be able to spin up 20 servers and have them pound this piece of code I'm taking out. I want to take a server and I want to see what happens if I do X. In fact, we'll talk about experimentalism in just a moment. They're going to have a cloud environment for big data. Now, I'm going to return to big data and analytics. But some of the vendors who are very good at big data, well, I shouldn't say that. There aren't really any out there who understand this space. And this space is about to explode. I'm going to spend some time on this, so I'll just skip over it for a moment. But many of them who are getting into big data, and I'm talking about enormous data sets, are saying, I don't see a cloud vendor out there who can really support me in my needs. I can get a bunch of bare metal, and I can spin stuff up, but I don't really, and most of them think somebody's going to come forward and claim this space. And then, of course, I want to have a bunch of SaaS offerings, and I'm going to have them integrated in my organization. Okay? What does that mean? It means they're going to have a mix. They're going to have a mix of delivery and deployment, and they're not going to spend a lot of time looking back at that diagram saying, okay, now which block does this fit in? Which delivery model, which deployment model am I going to be looking at when I do that? So I'm going to give you two important takeaways that derive out of this, corollaries. If you don't believe the thing I'm saying, the next two points don't matter. If you think what I'm saying might have a piece of truth, these are two trends I think are being driven out of this. Whoop. The first one is the advent of the cloud collective, as I call it, is going to result in integrated ERPs. I'm talking about the SaaSes and the Oracle Business Suites of the world, and all those people who compete for that giant ERP are going to be nibbled away with extensions with third-party best of breed. We're almost going to be reversing the path we were on where we said, well, should we have best of breed or should we have an integrated ERP? Now what we're going to discover is, because of SaaS offerings, where we can leverage up a SaaS offering on a transaction basis because we have a particular type of transportation, less than a full load on a truck. And by the way, it's got to go to Fort McMurray. And there is a predictive transportation piece that does that really well. So we're going to be extending it. I'm not suggesting SAP goes away. I'm not saying Oracle goes out of business. What I'm saying is we're going to begin extending them with SaaS offerings in a way we haven't thought of, and it's going to be transaction-based. Transaction-based. And that's going to be driven completely by business values. Now, I think new firms are going to emerge. I think there are going to be new firms that are going to emerge that are going to help you manage your cloud collective services. Today there are a few firms that help you with billing issues, the cloud verticals of the world out there. But there are groups that are going to take roles like Russell Investments. You know, has anybody in here ever heard of Russell Investments? I'd be really surprised. They are more than twice as big as the Investors Group. The reason you never heard of them is they don't talk to you. They don't talk to consumers. They don't talk to mortals. Frank Russell came up with an idea almost 50 years ago, in which what Frank Russell said is, you know, betting in these mutual funds and making investments is a tough business. So he developed a model, and you'll see like Russell indexes being quoted. And his model was, we're going to study funds and the managers of funds, because every manager has a distinct personality. They will take risks a certain way, they will make investments a certain way, and they will drive returns. Russell's, in fact, the biggest manager of retirement funds. But they don't put the money in Russell funds. They take for 0.2 of a mil managing half of IBM's retirement and half of Hitachi's retirement, and they then manage it in all of these Fidelity funds and all of these Vanguard funds across the board. Well, we're going to see firms emerge like that, except they're going to do this for all of your cloud computing. Because there's a lot of gnarly configuration administration that needs to go there. You have to sit down every month and look at all your instances you've got up and running in AWS, and should we turn them off, and should we convert them, and do those kinds of things. And they're going to take over that responsibility for AWS and others. And it's going to be kind of a manager of managers model. In fact, in the old network management days, we had these kinds of firms doing these kinds of things, looking across multiple management capabilities. That capability is going to emerge. Because I've got clients, and they're asking for it. They're asking for it. So somebody's going to go into that space. Fourth takeaway. Do not go to the cloud for the purpose of reducing IT costs. It's not a reason to go there. Now, if somebody says to me, Larry, I want to go to the cloud because I got to drive down IT costs. And I say, is that your only driver? Yes, I got to drive down IT costs. They've probably got a whole nother problem. Their company's in trouble and everybody's got to cut costs, or just IT has to cut costs. And that's about a vote of confidence in IT. It's management saying, we don't think you're doing your job, we don't know how to tell you what to do, so the only thing we know to do is to tell you to cut your costs. By the way, there are lots of other ways to cut costs than simply try and move to the cloud. Now, I certainly think you're going to reduce your costs. I took a company, mentored them all the way through, which had no background in the cloud, not one SaaS service. We drove out over 75% of our production costs, and that's a little case blip that we'll see in just a second. We did that in 6 months. Their availability was under 95%. Now these people are tied entirely to the internet. And we went up to 4 nines and took out 85% of the cost base. But we didn't go there for cost purposes. That's not why we did it. We went there because of business drivers. The company had to scale. The company couldn't change the way they were doing business. The company had no analytics capability. They were out of capacity on their phone switch. They were out of capacity in storage. They were out of capacity in their email system. Stuff was falling apart, and it was completely undocumented. And they wanted to grow the business 5 to 10x in 3 to 5 years. And they wanted to have the cost of IT as measured as a percent of revenue to decrease. And they gave me 8 days to have the strategy. Actually, as of last night, I had slides from that deck that I put up, and the answer was the cloud. If you're going to bet all in, you're going to tell me I can do whatever I want, and you trust me, and they had actually tracked me down, and it turns out they were only 20 minutes from my house. I said, this is what we're going to do. Now, IT costs didn't go down. In fact, IT costs today are even higher than they were then. But what they did, and any board will take, is every dollar we took out of the cost structure for feeding servers and having support staff. We had 3 colos, Net Intelligent in Montreal, Primus in Ottawa, which I think Rogers bought a few months ago, and a Rackspace, one of their facility in Dallas. Rackspace has got a facility. We went from 3 colos to AWS. Every dollar saved, we invested in data warehouse, BI, and big analytics. So IT costs didn't go down. But the dollars got put to greater business value because we could repurpose the dollars. So I don't deliver a cost-saving story when I'm talking to senior leadership. I may say the way you're going about it, we can dramatically reduce costs in this area, but maybe not so much in this area. But what I can do is I can drive business value. And that, I believe, is a story that the board really wants to hear. Takeaway number 4. The reason to go to the cloud Well, not cost, it is business value. And I'm going to give you two sets of drivers. When I'm talking to business people, and I'll do this, not even tell them I'm there, they'll say, here's a really smart technology guy, he's been on a couple of boards, we'd like you to talk to him. What I want to ask them about is, tell me about new business capabilities that need to be implemented. A survey of CIOs in North America done a few months ago, 83% of the CIOs said that analytics was the single most important technology that their company could invest in that would improve the company's competitive position. Well published study. They're all about analytics. Enable business agility. We want to be able to change faster. We want to drive growth. We've got an aging workforce and it'll go on. Those are business drivers, most of which can be aided if you approach the cloud correctly. On the IT side, aging infrastructure. Being out of capacity, server capacity, storage capacity, network capacity. A reason to look at cloud computing. Shortage of skills. You know, I'm not telling you to get rid of Exchange, but when I go into a shop and they tell me we need to repurpose our dollars and think about better use of our head count, I'll say, okay, let's take the Exchange and let's move that out. And you can go through a whole ton of exercises like that and a whole list of other things. Driving business value really requires IT to think about the art of the possible. The art of the possible with cloud computing. And what I thought I'd do is give you a couple of examples of that. Let's talk about, most importantly, this explosion in big data analytics and predictive modeling. A concept I introduced to some of my clients is a concept I call fact sets. And years ago, I was on the board of Cognos. I worked for NSA for a number of years and ran their the technology base, the database platform that enabled their second largest intercept database. So I spent a lot of my time in deep analytics, although I came at it as an IT person. And my concept of maintaining fact sets is this. When you have a fact, don't ever get rid of it. Keep it. And while you may not ever figure out today how you could ever use this fact, keep it, because you never know. A great example is SCADA data. If you're in utilities or E&P, any place that's got process control equipment, all that data that comes flooding in, 10, 20, 30, 40,000, 50,000, 60,000 data points an hour, some organizations a minute, some organizations in a second, comes flowing in. What do we do after 3 or 4 months? We get rid of it. Keep it. In fact, keep all the data in its native primitive form. Don't put it in the data warehouse. So I put it in a fact set, and I take that stuff I want to normalize and put that in the data warehouse in my BI. I just save it over here as a breadcrumb. You never know when you might need it. And I do that because, look at my curves. Think that storage is free. A terabyte of storage on Glacier is $10 a month. A terabyte of storage. And by the way, that's the published price. You can look that up today online. $10. By the way, it's easy to use. It uses the S3 interface if you're familiar with the simple storage service that AWS have. Keep all your data. Now we have new technologies. Hadoop is only, Yahoo guys laid down the first code just in 2005. It's exploded. Take a look at the number of SaaS offerings today and SaaS offerings just a year ago in BI. Go and take a look at Prism and Sisense. You won't even recognize Cognos if you haven't seen it recently. This space is absolutely exploded. I'm going to give you one example. This is an area I've been doing some work for IBM in, because I got both a background in E&P and in utilities. It's a notion called predictive maintenance. Boeing and GE are making huge investments in this space. When I say huge, Google airplane health management and see what you get. And the idea is very simple. Don't do preventive maintenance. Don't do condition-based maintenance. Don't do scheduled maintenance. Create a predictive model that will tell you when you need to maintain it. Now, what's different is you don't use a gauge. You use those thousands of pieces of data, none of which put it in the red zone or the yellow zone. But when added together, you can correctly predict that something's about to fail. A utility recently created a predictive model using exactly this capability, and they had kept all their SCADA data for 3 years and all their tickets. They wound up determining that a gas turbine, which they used to have 30 minutes of warning the gas turbine was going to go down, they now have 30 hours. Now you tell that to a board of directors and they're talking about keeping assets online. By the way, the maintenance is way cheaper when you do it then. The other thing is you can use your warranties better. And this isn't true just for utilities. BHP in Asia had a mining operation, and they would have vehicles break down. These are the monster trucks like we've got up in the oil sands. By the way, I once spent a January in Fort McMurray for Suncor, which was the experience of a lifetime. So imagine these monster trucks, and they have maintenance problems, and they have loads they have to get out, get ore shipped to China, and all these kinds of things. And they had a difficult time predicting when is a truck going to fail. Half an hour in SPSS, you know what SPSS told them the biggest variable was? The gender of the driver. The biggest single variable, and nobody had seen it. Nobody, and by the way, the good news is it's about women, which is why they should all be the bosses. You know, when I grew up, and I'm 63, when I grew up in the 60s, my mom decided she wanted to try a job. She had a college education, we moved around. So she took a 2-month college learning program and learned RPG. 3 months later, she was the head of IT in the local college, Palomar College, Mount Palomar Telescope. And I thought all moms were programmers, and I always thought women were supposed to be in charge. And of course, Michelle knows my wife and understands why I would think that way. So, takeaway 5: big computing wins. I'm going to say it differently. We are in the Stone Age of business intelligence and predictive modeling. We're in the Stone Age. The revolution is coming because now we can store all the data for nothing. Remember those curves we had before? We get all this processing power and we got all the network. In fact, let me tell you what Boeing's doing right now. Boeing, and this was built on the B-2 bomber. When planes are in flight, the plane is constantly sending all of its data to ground stations, which is doing predictive maintenance while the plane is flying. If the plane needs a part replaced, when the plane lands, the plane will tell the maintenance crew what part needs to replace, how to replace it. That's all in the plane and where the part is. And by the way, that part may not be in Air Canada's locker. It may be over at WestJet's locker. But now, for those planes, Boeing knows all the spare parts. So we can say to the Air Canada maintenance person, walk over to WestJet or Delta or wherever and get the part. Because all the planes know where all spare parts are in the world at all times. Airplane health management. They rolled it out on 787s, 747s. By the way, it's going to cover some of their earnings losses. It's a huge play. And GE, they're doing this for all of the gas turbines worldwide. A predictive model. By the way, think about the margin they're going to make. I can improve the availability of your gas turbines by 5%. Think about return on assets. It's enormous, and this is true in any capital-intensive industry. Railroads, airplanes, ag, grain elevators, enormous. Oh, takeaway 6. The integration of SaaS offerings, again at Stone Age, is going to allow us to solve seemingly impossible problems. And I've got a case study. This is another one of my clients. Internet marketing company, 250,000 visitors a month. 98% of all their business is driven through search engines. At any moment, they're managing 200 to 300,000 keywords. They change about 5,000 bids a day on average. So they're pretty busy. 75% of their sales are online. They have a close rate of 1.5% to 2%. It varies. So conversions, 1.5% to 2%. If the person's on the website and they have a question, which a lot of people do, then what they do is they call the 1-800 number. It's all inbound sales. If they call the 1-800 numbers, the close rate's 25 to 30%. More importantly, the average transaction goes up 5x. 5x. It's enormous. If we can get them to call us, and a lot of people are turned off by that little chat window thing. I'm not, because I actually don't like talking to people. I'd rather chat and text, you know? So, what are the impossible challenges? So the company said to me, Larry, how do we determine the return on investment of keyword searches we do on the internet that drive telephone sales? And oh, by the way, not only do we have to do it in real enough time that we can adjust our bids, because that's like, it's like the stock market, bidding on keywords. And by the way, how can we do it cost effectively? Because our margins are razor thin. You laugh. Are you out of your mind? You can't do this. Well, it turns out actually you can do this. So I went out and I bought several technologies. We picked up a product called Site Catalyst for web analytics. Used to be the old Omniture product. We bought it. I think it's, I forget how Adobe's relabeled it. So think of it as Google on steroids. Bought MarchX for call tracking. You probably haven't heard of MarchX. Great technology. I wish I owned it. MarchX to every web visitor presents a unique 1-800 number to that visitor. A unique 1-800 number. So all the session data that person sees is tied to that 800 number. Then I threw away the phone system. It was out of capacity. They want to be able to grow 5x. What stands in the way? PBXs. If you've ever dealt with phone systems, anybody in IT, my first gig as a CIO, I had to deal with the phone system. It's like a nightmare. First, phone people are like their whole own subculture. It's like the difference between goalie and hockey players. So just like a different universe. So I decided, well, let's strip out the phone system. So I bought something called ShoreTel Sky. It is cloud-based telephony with queues and queue structures. In fact, 2 weeks after we installed ShoreTel Sky, our average transaction per inbound telephone call, remember we only close 1 of 5, average transaction went up $5 per call. Because we could adjust the queues, and whoever was selling better at the time, they went to the top of the queue. They got more calls. People who weren't selling, they went to the bottom of the queue. This is as rich a function phone system as anything I've seen, and there is no phone. We use Cisco routers and Cisco phones, and we can do soft phones if we want to. And it took a little bit of integration magic. And in fact, the programmer for that I found in Ottawa, of all places. So takeaway 7. IT staff, we have got to change our focus. We've got to evolve our skill sets across the board to be successful here. Stop doing capacity planning. I'm going to say the dramatic thing. Cloud wins. Capacity planning is dead. Dead. Forget it. Don't do it. It's a waste of time. Now, I'm being dramatic now. You can buy me a beer later. Don't do capacity planning. By which I mean we do too much when you get in the cloud space. Don't do in-depth analysis. Not like we're currently doing. This is highly qualified. That's why I got a little asterisk at the bottom. Don't worry about configuring so much. And by the way, stop worrying about your job. There are lots of jobs here if you embrace it. What do you got to learn more of? Horizontal scaling. If there is something that clustering failed to do, was it failed to introduce you to horizontal scaling, because it's a different way of looking at the world. You've got to understand horizontal scaling. You've got to be willing to experiment. You don't need to come to a conclusion about cloud computing. Go log on to AWS right now. 753 hours of Linux a month. A month per person. You get that for a year. Anybody logs on. You got 10 people in your DBA group or 50 people in your IT shop? Boy, that's a lot of hours. And it's free. And you can do anything you want to. You can start a server, you can kill a server, you can do all kinds of things, and you got to read about the cloud, and you got to do visioneering. When I say visioneering, I mean visioneering about adding business value. So we need a lot of skills that we got to improve. DNS. You got to know that call to get into the cloud. You better know firewalls. Now, a number of my clients have begun outsourcing firewall management because it's gotten so tricky, and you want to keep it up to date. You got to understand SLAs. I've gone into disasters, not just with SaaS and other things. People don't read their SLAs, and they don't understand it, and they don't understand pricing. They signed an agreement and never did an economic model. And you saw my curves before. I'll show you how to do economic models in a moment. So I'm going to give you 2 examples. First, I'm going to give you an example of horizontal scaling. And secondly, I'm going to give you an example of, well, the parenthetical phrase is, forget capacity planning. The polite title is New Age Server Sizing in the Cloud. This is how you do it. Experiment 101. So, horizontal scaling. Background. Went to a client, website's at capacity. I mean, it is redlined at capacity. Partly, a lot of page views. People would come on, the average visitor was 6 to 8 page views, any time of day, including 3 o'clock in the morning. The graph below illustrates traffic during the week of September 23rd to 29th. Classic curve, that's Eastern time zone. Doesn't really matter, but these are visitors coming in. We got Sunday first, so we go Sunday, Monday, always the busiest day, all the way through the week, and then down to Saturday. Call center not open on either Saturday or Sunday. Classic curve, out of capacity. And you get a bigger bump on the first of the month. So this is actually the quietest week of the month, most predictable, 3rd week of a month. So, what's the traditional approach? out of capacity, buy a bigger server. How big a server do you get? We get a server big enough to cover your peak and then some for the first of the month. Classic capacity planning. And we can buy models and we can put crap in them. But then there's the other approach, horizontal scaling. Now, I learned everything I want to know about horizontal scaling because I was in the board of a company called Golden Gate. Golden Gate, which got bought by Oracle, which of course ruined them. But Golden Gate is used for 60% of all the airline reservations in North America are enabled because of Golden Gate technology. So you log on to Sabre today, you look up all the prices. WestJet uses Sabre, others. You know, I want to see all pricing, all scheduling, all opportunities, everything I can see. Travelocity, there are like 6 big travel services that run on Sabre, and of course lots of reservation agents. So you log on there and you look at prices and you surf all around. You see every flight, every airline, every combination, every pricing combination, day of the week, move forward a day, move back a day. Everybody know what I'm talking about? What computer does that run on? It runs on an Intel box made by HP about this big. It runs Linux and MySQL. And they have 700 of them. And they took $20 million out of OpEx in the first year. And Golden Gate does all the replication, 200 milliseconds or less. Only when the magic, if you're a programmer, old school, you know the meaning. Only at the magic moment of commit, when you hit buy, does it flip you over to actually a tandem, HP nonstop, to actually do the credit card transaction. Everything else is running a platform. By the way, Wall Street does that. They do that. They do horizontal scaling. What is horizontal scaling? Well, use a bunch of small, cheap computers to do this. And what we did here with auto scaling is very simple. We drove down the price enormously, and by the way, we did it on demand. We got a medium reserved instance that ran 24/7 all the way across. We get another instance that runs about 40%. So figure out, oh, maybe the first half is done by the first medium instance. The next half is covered by one that runs only about 40% of the time. And then we have a third one sitting there on idle, or fourth or fifth or 100. You get spun up anytime demand requires it. That's all it does. Just auto scale up and down. And this is the way websites are being built. I'm sure this is the way Netflix is built. And Heather's going to be up here talking, and Heather's just got some great stuff. I mentioned how happy I was to see George again, and Heather is absolutely terrific. She'll bring you some great info. So what is this? Capacity planning is useless. Well, I didn't really say that. But this following conversation took place. This is not verbatim, but this is practically verbatim. If I was in a court of law and I was asked, did a conversation like this occur in a 3-minute period, I would say yes. So a senior engineer came to me, Walter, and we were trying to figure out how much horizontal scaling, what should the first base server be in that? What is it? Is it a micro? Is it a large? Is it large with extra memory? What is it? So Walter came to me and he asked me this question. Okay, Larry, how big a server should I do to run our experiment? We're going to start bleeding off traffic on Amazon. I said, oh no, send all the traffic over there. Let's see what it can take. And he said, well, what do I do? I said, hey, we got to do some analysis. I said, no, just go get a big, large with a lot of memory and run it for 24 hours. It'll tell you what size box we need. And the answer? A medium. I let the traffic tell me the capacity. And when you take this approach, it actually works. It is a leap of faith, but it works. It works. And the consequence of that, well, lesson learned. Let performance determine capacity. Takeaway number 8. You've got to fully understand pricing. You know, there are a couple of things we don't do well in IT. I mentioned SLAs before. I'm going to talk about pricing again. We don't really work at understanding the way the pricing model works. We talk about pricing, and we look at the price list, but we don't really get it. Well, I got to admit, it's hard, and I can't state this strong enough. You've got to learn it. I'm just going to give you 2 gotchas. One of the things SaaS vendors like to do, I've actually got SaaS contracts like this. You give them a range of users that you'll have, but if you go over the highest number you tell them, then your rate goes up. And the argument is, well, we couldn't effectively plan capacity because you misled us on how many users there would be. So you pay a penalty for using it more. By the way, this is in way more SaaS contracts than you think. I bet you didn't read that clause. Another one is incorrectly estimating the amount of data you're going to take out of a cloud environment. Because they tend to say, oh, it's free to go in, and we charge you a small fee to take out. Well, misestimate that, and you're going to blow your budget. Just get it right. Learn the price curve. So what do? We build spreadsheets. And I always say, model the extremes. Model the extremes. So I'm going to give you a couple of examples. Now, I want to be clear. These are the spreadsheets I did for AWS for a client. They're a little dated. I've done them before. These are the first ones I could put my hands on. So the numbers don't reflect AWS pricing today. The important thing is the intent. So AWS is great about telling you all their prices. I took this off their website at 6:41 today. This is the price list, a la carte, full disclosure, transparent, which means it's useless, for medium Linux servers, 1-year term and 3-year term, reserved instance, which basically means you pay a fee up front, a flat fee for 1 year, flat fee for 3 years, you pay up front. And then depending on which one of those you do, you pay an hourly charge. And that hourly charge is deeply discounted against what you would pay if you bought it on demand. Simple. But you got to understand the curves. And you don't get it from any of this. So, everything I just told you, I think. AWS is going to give you this. You're not going to be able to figure it out. By the way, they're always introducing new offerings. It's stunning the rate at which offerings are coming out. And they've introduced a trade-in program, which they desperately needed. So you miscalculate the number of reserved instances you needed. You needed a large instead of 2 mediums. You can trade 2 mediums for a large. You had a large, you can get 2 mediums. You can do that trading. There is no penalty because they'll trade either way. So they allow you to buy down your capacity cost and then trade it like Lego blocks. It's like monopoly money. And the other thing that a lot of people get wrong about AWS is you're not tied to using an instance for something. You have so many instances, you have so much work, and they net it out at the end of the month. So how do you take advantage of it? Well, here's one example of a curve for medium instances that I did. I built the mother of all spreadsheets. So this is a clip of the top. These are some rates over here. This is time by month going forward, different kinds of assumptions, different utilization rates. So it's a spreadsheet. This is the top piece of it, one of the drivers in it. And then I mapped everything. I said, show me the price curves and how they map to each other. So here's an example, and I got lots of these curves. In fact, at one point I actually thought about a business. I could be the AWS pricing maven and have people pay me to do this for them. So what you find out is that the Linux reserve instant breaks even versus on demand at about 46% utilization. By the way, that's 24,365 when I say 46% utilization. A Windows reserved instance breaks even at 27% utilization. What does that mean? They want you to buy Windows because they don't want to give it to you on demand. They want to incent you as much as they can. And the reason they do that is because of the Windows tax. Windows costs them a lot to run the licenses and have support. So in fact, a Windows server is 47.3% higher than Linux, the same instance, when you do it reserved for a year. When you do it on demand, a Windows server, same bare metal, is 76.9% more expensive than a Linux server on AWS. They're trying to drive your behavior. By the way, what they're sharing with you is their underlying economics of those models. So you have full disclosure. Just understand these. Now you got hundreds of breakpoints, and let me give you just another example. Simple storage service, or S3, as it's referred to. Again, here's my spreadsheet. Here's the data that drove it. These prices have been cut since then. So first terabyte is 125. I'm sorry, 12.5 cents, and that should be a gigabyte. But it's only a typo. So S3 prices have dropped 24% since I did this. So a gig went from 12.5 cents to 9 something for standard, and then reduced redundancy went down further. So I just basically drew curves. So I took this out to a terabyte and a petabyte and whatever, and I could actually see the inclinations, where they separated out their pricing, and where if you moved to a certain point, you could see the change in their pricing structure. They give you all the numbers, just nobody puts it into a model you can run. It's easy stuff. So in fact, $95 a month gets you a terabyte in S3, and as I said before, $10 gets you a terabyte in Glacier. And that's before the volume discount. That's before the volume discount. Okay, takeaway 9. Do a rapid assessment of opportunities for cloud computing wins. Business drivers, we talked about. IT drivers, we've talked about. These are things that I look at in an organization when they say, Larry, We want to get our foot into the cloud. Where's the best opportunity? And I look both on the business side of the house and I look on the IT side of the house. Where are the biggest opportunities to drive big value? Because I want the first one that we're going to use for an educational experiment to drive huge opportunities. And some of my targets, which I'm putting over here on the far right, Exchange, I mentioned that. Content management, data warehouses, because they're growing. We always need more capacity. Fact sets. Websites, because of the scalability problem. So you've got something successful, you better have horizontal scaling. Perfect to move out. Perfect to move out. Fact sets and all the new analytic stuff that I talked about. Now, when I say rapid, I'm not talking about a lot of wringing of the hands. I'm talking about 2 to 3 days we take and we do that kind of assessment to identify those opportunities. And it includes the business case, so you can talk to the CFO, or the CIO can talk to the CFO and say, for example, in an asset-intensive business, this is what it means for return on asset. Or if they're earnings focused, this is what it means for earnings per share. This is what it means for free cash. These kinds of changes. If you can walk in and say, you know what, we'll pick up a nickel a share, a nickel in earnings, that means $1 a share, people are going to listen. Now, again, I don't start with cost. I start with business value. And that's really what business wants to hear. All the financial stuff, that's just icing on the cake. So real quick, I've taken a bunch of clients through this as an advisory role, doing assessments. I had one client where we went from dead stop to the cloud in 6 months. Now, there were some things about that client that were unique. IT staff was very young, very smart. They didn't have any vendor biases. They didn't say Oracle's the greatest thing since sliced bread, or I will only ever buy EMC, or, NetApp saved my day. So they didn't have any of those biases. The other great thing is they were naive. They had no idea what I was asking them to do. They thought it was an adventure. Okay, lessons learned. So, takeaways 1 through 4. Cloud computing wins because of the underlying economics. 2, cloud computing taxonomies are great for comparing and contrasting, but it is way more complicated than that. The range of offerings are much broader, and you can create new offerings that nobody else has done. 3, don't forklift your data center, or you're going to get outsourcing circa 1997 all over again. That's not what you can do with the cloud. Instead, think about a cloud collective, because that's what I think I'm not telling you to go build a collective today. I'm saying when you look out, where might you be in 2 to 3 years, it's a collective of cloud offerings, and you're still going to have some stuff in-house. You're still going to have stuff in-house. 4, the reason to go to the cloud is not cost. It's business value. 5, the big demand, the hidden demand in boardrooms, so you may call them dashboards or business intelligence or deep analytics or big data, that's where it's going to be. We have new trends. Predictive maintenance is just one of these things that's going to explode. It's going to explode because we can collect everything over networks, because networks are ubiquitous. Everything is intelligent. Everything has embedded measurement in it today. We can process it for nothing, and we can store it for nothing. Well, not nothing, but we can store it for a long time for near nothing. That's going to cause this to explode over the next year. In fact, I used to tell people 20 years ago, they'd say, what should I be when I grow up in IT and I want a job tomorrow? Enterprise architecture. About 10 years ago, they said, where can I make the biggest money? I'd say, well, InfoSec is a great place to be. Today, big data analytics. If one of my kids was coming out of college today, they say, Dad, what kind of a job should I get? I'd say, go into big data. That's where the big salaries are going to be. When I hire a data scientist to give me some consulting on big data, and these are the PhD types, and I'm paying him twice the daily rate that I'm charging the client, you know what? That's the place you want your kid to be when they get out of school. Okay? We've got to improve our skill sets. We really do. And, I was making jokes about capacity planning because I want you to think different. And part of this is going to be managing SLAs and understanding pricing models. You've got to understand those, and you need to absolutely change your skill sets. And finally, do a rapid assessment. Do a rapid assessment. Don't spend 6 months, say, we're going to take 2 days, we're going to move through the business, we're going to move through IT, and all we're trying to do is identify the best targets of opportunity to run a POC or run some experiments. So with that, you know what we're going to do? We're going to take a break until about 2:30, I think. George, is that right? We got 10 minutes. Thank you, and I'm going to be here for the break and certainly after 4:45 or whenever we end. Thank you.
Thank you.